So this is just a review in case you need help in this unit simplifying radicals when you're doing the distance formula or finding the distance between any 2 points. And we're going to use it later when we do special right triangles. So using the Pythagorean theorem, usually you wind up with a radical at the end of that, and you'll need to simplify it in order to give what we call simplest radical form. And that's usually the form that tests and things like that want you to give it in. And that's simply because if we didn't get it in simplest radical form, everybody could have a different answer based on the perfect squares that they took out. So this is the preferred form for a radical. And if you remember, a radical simply means, it's a fancy word for a root in math. So the first thing you need to remember in order to be able to simplify radicals is your perfect squares. And I know we've gone through these a lot, but I don't really start with 1 because that goes into everything. So I usually start with 2 squared, and that's 4, and then 3 squared is 9, and then I just continue. So 4, 9, 16 is 4 squared, 25, 36, 49, then we go up to 64, 81, 100, 121, 144, and then the last one that I usually know is 169, which is 13 squared. And after that, you usually don't get things that are bigger than that for perfect squares. Some people will know 15 squared, which is 225, but it's not super important. So I would know up to 13 squared, and you can skip 1. So those are important because we need to know whether or not those go into radicals in order to be able to take them out. So let's do a couple of examples how you would simplify different radicals. So we'll start with an easy one. So if at the end of the Pythagorean theorem or some sort of algebra equation, we got square root of 25, well, I think to myself, 25 is actually a perfect square. So if it's a perfect square, then you ask yourself, what was squared to make this number? And that's the square root of it. So this one simplifies to exactly 5. All right, so let's do one that's not on this perfect square list. How about we have the square root of 37. So in order to see if we can simplify a square root, sometimes we can't. We go down our list of perfect squares until we get to the perfect square that is larger than this number. Then we know we can stop. So I go down and I'm looking at 37, and then I look at my perfect squares and I think, does 4 go into it? No. Does 9? No. Does 16? No. 25? Nope. 36? Nope. Then I get to 49, and that's already bigger than 37, so I know I can stop there. I don't need to keep checking because none of these bigger numbers will go into 37. So this one is simplified as is. You can't simplify it anymore. It's totally done. Let's do a little bit of a different one. How about the square root of 75? So now this one, I'm thinking it's not prime, so I might have a perfect square that goes in. So I'm going to start checking and thinking about which of these perfect squares will go into 75. And then I'm going to split my radical into that. So property of radicals is that you're allowed to split them and have a multiplication in between the two. So I'm looking over here and, oh, I think 25 goes into 75. So I usually put the perfect square that I'm splitting into first. So 25 times 3 made 75. So I split it into just 2 factors of 75 with the perfect square factor in the front. Now I know, because we did it over here, that 25 simplifies to simply 5. We can remove that square root. But the 3, nothing else goes into that in terms of perfect squares, so it stays underneath the radical at the end. So there's my answer. Square root of 75 in simplest radical form is actually 5 root 3. Let's do just one more. So sometimes you get a really big radical on like a challenging problem, like the square root of 1,302, or 32, excuse me. So in this one, I'm thinking about my perfect squares and I'm thinking, oh gosh, I really don't know what perfect square could possibly go into this number. So what I'll start with is one of my easy perfect squares. So it's pretty easy to check if 4 or 9 or 25 go into a big number. So I'll start with 4. So if I check, does 4 go into 1332? Well, it goes in here 3 times, remainder 1, goes in there 3 times, remainder 2. Did I get the wrong number here? Uh-oh. 2, 1. No. Oh, that would be why, because it's remainder 1. Sorry, James. So remainder 1, and it goes in there 3 times. So it goes in 333 times, 4 does. So I'm going to split this into root 4 times 333. And from there, I know that 4 can simplify to 2 when it's underneath the square root. And then 333, I'm pretty sure that's prime, so it is going to stay underneath the radical, and that is simplest radical form for this number.